So we're doing page 208, 1 through 30, talking about complex numbers. We kind of already looked at this yesterday. I didn't call it that. So, what did I stand for yesterday? You guys remember? Imaginary number, and it was equal to square root of -1.
Yeah.
So if you have something like 3i, that would be an imaginary number, or I squared of 2, that's an imaginary number. When some of our answers yesterday looked like 5 plus I squared of 2, or something like that. So when you add a normal rational number with an imaginary number, this is called a complex number. So it's something real with something imaginary added together. It's complex. That's what we're doing today. Basically, when you work with imaginary numbers, they work just like variables. So for example, if you have like 5i plus 2i, that's just 7i. Okay, so it's really not that hard. I know it's weird, the idea is weird, but how it works is not terribly weird. Okay. Alright. Here's something that's kind of weird though. I equals I, or you could say it's the square root of -1. What do you think I squared would be equal to?
1.
-1. Because the square and the square root cancel each other out, so it's -1. So here's a weird thing. I is an imaginary number, but I squared is a real number. So, yeah, that's weird. Okay, what if I did I cubed? Well, I times I is -1, times another I would just be -1i, or -I. So I cubed is an imaginary number. What if I did I to the 4th?
-1.
Well, it'd be -I squared. It's this times another I, right? You just do that times another I. So it'd be -I squared. What was I squared? What did we talk about earlier? It's just -1. So it's basically -1.
Which is 1.
Which is +1. That's real.
Okay, what is the
Okay, what if I multiply another I to the 5th?
Positive
I.
I.
Wait.
Positive I, how'd you get that?
Oh, it's just going in order.
It's 1 times another I, right? It's I to the 4th times another I. So it's just I. So guess what I to the 6th is going to be?
-1.
I squared, basically. That times another I is I squared, so it's -1.
So it just starts a cycle.
Oh, then it goes
Yeah, there's a cycle here, yes. From there to, so I to the first power is just I. Second power is -1. Third power is -I. Fourth power is 1. And then it starts repeating itself, because when you do 1 times I, it just kind of starts all over again. So what if I said something like I to the 27th?
Go by 4s.
It goes by 4s, but how can we figure it out? Well, basically, you divide by 4, and then you figure out what the remainder is. What's 27 divided by 4?
8. No, that's 32.
20.
7.
Well,
That's not pretty
close.
good. No, I'm gonna show them how to do this.
Okay, 27 divided by 4 is 6. So basically, it would go through the cycle 6 times, with the remainder of 3.
So you go to the third.
So it'd be the third one. Yeah, so it'd be -1. Okay, so it's like we're taking out, a bunch of 4s, and the remainder tells us where it ends up at. You guys want to do that? Well, we'll do it on the homework. All right. real, Simon really is, I think it's easier
It's
than,
probably easy,
last
but we
few.
just haven't figured.
you haven't
out
seen it yet, yeah.
Oh,
Shoot.
numbers what?
208, 130. Actually, yeah, I'm gonna edit that. Let's do page 208, 1 through 4, and 13 through 36.
I don't like that, 'cause it definitely added some.
I don't think he did. I think he took some out.
Didn't add it.
He took the graph and front out. Oh wait, never mind, the good ones before the graph.
There, changed it. Okay, so number 1, it says write each numerical standard complex in standard complex number form, a plus bi. So 7. There is no imaginary number on it, so what they want us to do is just write plus 0i for that part. That's in complex form.
Okay.
So number 2, it just has an imaginary part of the complex number. So what do you guys think for number 2?
It'd be whatever that is and then 0 in front of it.
Yeah,
It'd be 0 minus 6i.
yeah, just be 0 minus 6i. Okay, number 3, we actually need to do a little bit of work. What do you guys think for number 3?
Well, we've got to get the thing off of there. The square root.
Yeah. So the negative comes out as an I, right?
Mm-hmm.
I think we did square root of 8 yesterday. You guys remember what it was?
2 and 2.
Yeah, 2 square root of 2. 2 square root of 2. So it's 8 plus 2i square root of 2. Alright. And, huh?
Yeah.
How would you do?
Okay, both of those just get divided by 3 separately. It's kind of like distributive property. So what's 2 divided by 3?
2/3.
2/3 minus, what's 6i divided by 3? 2i. That's it. Okay, number 13. So you guys remember earlier how I said the I works just like a variable in normal situations? So when we're adding those two parentheses together, we just add the like terms, basically. When you add parentheses together, you don't really need the parentheses because you're just adding 3 and you're adding a minus 2i. So the parentheses don't really do anything on 13. So basically it's 1 plus 3 is 4, and it's negative 6i plus negative 2i. What do you think that'll be? Negative 8i. So it's 4 minus 8i. See what I'm talking about? Easy peasy. Shouldn't have said that. Okay, 15. 15 has a minus in front of the second parentheses. That does make it a little trickier. So basically on 15 we have to do 5 minus negative 2. So that's 5 plus 2 is 7. Then we have to do negative 8i minus negative I.
That's adding 1 to the b.
Right, so it's negative 8i plus 1i, which is, what's negative 8 plus 1? Negative 7, so it's negative 7i. Okay, 17 was that thing I was doing over here, basically. I to the 8th, what is that going to simplify to?
How do we figure that out?
Just I, right? Or no 1.
No, Well, if you divided 8 by 4, the remainder would be 0, right?
So 4 by 4.
Yeah, well, yeah, it'd be like I to the 4th. It's basically, it's I to the 4th times I to the 4th. And I to the 4th is just 1. If your remainder is 0, when you divide 8 by 4, that's basically that one right there.
So we just put 1.
Yeah, it's just 1. So if your remainder is 1, use I to the 1. If your remainder is 2, use I to the 2. If your remainder is 3, use I to 3. If you're not going to have a remainder of 4 because you have to divide by 4. Anyway. 19. I to the 83rd. So what do I need to do?
Divide by 4.
83 divided by 4. What's the remainder going to be? Whoops. Yikes. Remainder of 3. So that would be like I to the 3rd.
So you're negative I.
Right.
Is there a way you can check remainder on the calculator calculator?
You could change your answer to a mixed number, and then the remainder would be the top of the fraction. Usually, not always. Depends if the fraction reduces or not. So, kind of not, kind of yeah. Okay, 21. All right, what do you guys think? What should I do? Distribute. So, Nevaeh, what will it be?
-6 plus, I'm not really sure. Can you just multiply with that?
Yep, just treat I like a variable.
Oh, okay, minus 59.
The one time you can't treat I like a variable is when you do I times I, because then it turns into -1. But for normal things like adding, subtracting, multiplying, usually you can pretend it's like an X. Okay, 23. What kind of problem is 23? Foil. So we will have to do I times I on this. What's the first going to be? 6. What's the outside going to be?
-1.
No.
-3.
-3i.
Oh, I
Minus
said
3i.
an I.
What's the inside?
2i.
Plus 2i. And what is the last?
-1.
I squared.
Negative I squared. I times I.
Isn't that the same though as?
-1.
Okay. Yeah, I squared is -1, right?
Yeah.
So it'd be positive.
Right, so it's minus -1. So this is actually a plus 1 up here. So for our real numbers, we have 6 plus 1, which is 7. And for the imaginary part of the answer, we have -3i plus 2i
Which is
minus 1i, or just minus I.
Where did you get that?
Okay, it's just like a normal FOIL problem. We put our x's together in the middle. The only difference is on this I squared turns into a -1. So it turned into a plus 1. 6 plus 1 is 7. -3i plus 2i is -1i.
Okay.
Still no? Okay, you did or not?
No,
Is
no,
that-
no, no.
Okay. I got another trick. But it'll take a while. 25. 7 plus 2i. Alright, what's the first gonna be?
7.
7. What is the outside gonna be?
28i.
What's the inside gonna be?
2i.
Whoops, plus twice.
If you multiply two numbers with an I on the end, does it become I squared?
I'm about to find out, what do you think?
I think it would. Yeah, because I is treated like a variable, isn't it?
Right. So yeah, if these were x's, this would have been 8x squared, right?
Yeah.
So this is plus 8i squared.
Which is minus 8 because it's a negative 1.
Right, it's 8 times negative 1,
Uh-huh.
so it is minus 8. So on our real numbers, we have 7 minus 8, which is negative 1. And our imaginaries, we got 28 plus 2
30.
plus 30. They always put the real number in front of the imaginary number. Always, always. Kind of like we always put 7 in front of like x if we're doing 7 times x. Alright, so where are we at? 27. Back to kind of an easy problem. So we're back to adding and subtracting, not multiplying. So,
Distribute the minus.
right, distribute the minus. So let's start with the real numbers. What are we going to have for the real number?
Negative 4.
Minus 4, negative 4. And then 5 minus 6i is 5 minus 4.
Negative.
Negative 1i, just minus I.
That was easy.
Okay, 29. What do you guys think?
Distribute.
Distributive property. Alright, what's 1/2 times 4? What's
2.
2, so it's 2i. Okay, you guys know how to do this in your head without the calculator? Probably not. You can just do 4 divided by 2 times 3. That's basically what it is. What's 4 divided by 2?
8. I mean 2.
2 times 3?
6.
6. So this will be minus 6
I squared,
I squared.
which is plus 6.
Right. That makes it, yeah, basically minus 6, so it's plus 6. So it's 2i plus 6, but I shouldn't write it like this. I'm going to write it as 6 plus 2i. Switch the order. Uh-oh, 31. I'm glad we did this. Anybody have a bright idea for 31?
Divide by 6, the first part by 6.
Are we gonna have to multiply by 6 or just to get rid of the bottom one?
Well, we can't get rid of, we can't multiply by 6 to get rid of the 6.
So we divide by 6.
Because it's not an equation. If it was like an equation, like whatever's over here, then we could multiply both sides times 6 and we wouldn't change the value. Okay, but if it's not an equation, you can't just randomly multiply by 6 because that'll change the value and make everything 6 times bigger. Only when it's an equation can you multiply both sides by the same thing. To add or subtract fractions together, we need a what? Common denominator. What do 6 and 5 both go into? 30. So what do I need to multiply this by? 5. So I'll put it up here. Okay, the whole top need, whatever you multiply the bottom by, you have to multiply the top by. Because basically, if we're multiplying by 5 over 5, we're multiplying by 1, we're not changing the value. And right, we need to multiply, to turn this into 30, we need to multiply it by 6. Kind of ugly, but multiply top and bottom by 6. So this becomes, this one took some more work. 5 times 18 is 80.
That's
or 90, thank you, minus 25i. Okay, bring this minus goes with all of this, so I'm gonna think of this as a minus 6 when I distribute that out. So minus 6 times 2i is minus 12i. Minus 6 times minus 7
42.
plus positive 42. And what's the bottom going to be? What's the denominator going to be? 30, right. If the denominators don't do anything on adding and subtracting, it's just going to be a 30. Okay, but I still need to simplify the top here. Oops. Okay, so let's start with the real numbers. 90 and a plus 42.
132.
And a minus 25 and a minus 12i.
37.
Minus 37i. Okay. Here's the thing. I'm going to separate this into the real and the imaginary. So, in other words, both of these things are going to be divided by 30. Basically, this is like a distributive problem, but you distribute the divide by 30 instead of like multiplying by 30. So this is 132 over 30 minus 37i over 30. And I believe this is going to reduce here, right? You can divide both of those by 2 because they're even. So that will be 66 over 15. Nope.
You can divide them up by 6.
Yeah. Yeah, 66 and 15, 3 could go into them, so we can. But if 3 and 2 goes into them, that means 6 could go into this. So if I divide that by 6, that would have been 22. And 30 divided by 6. Remember, your calculators can do this, right? You just plug that over that in fraction form and hit equals. Like put it in as a fraction and equals, it will do it. Does this reduce? No. 37 is a prime number. It's not gonna drop. So that's our final answer. That's a doozy.
I think the rest of them are doozies. 32 kind of looks like it's doozy.
Yeah, a little bit. It's not those big fraction problems though. I think 31 was the hardest actually. Now that I'm looking.
We should have still stopped at 30.
Yeah, we need to do some hard ones. Alright. What do you guys think for this one? So, the cube means we're multiplying it by itself 3 times, right? So it's I squared of 2 times I squared of 2 times I squared of 2. Does order of multiplication matter? No. So that means I can multiply whatever I want to whatever I want, because all this stuff is basically multiplied together. The parentheses don't really matter. So, yeah, what should I do? Let's do the i's first, I guess. So what's I times I times I?
Negative I.
Okay, I cubed, right, which is negative I. And what's square root of 2 times square root of 2? 2 times square root of 2?
2 squared is 2.
It's 2 square root of 2. Well, whoops. How should I put those together? Well, the I we normally stick right there after the rational number before the square root. The negative will just stick out in front. So it's negative 2i square root of 2. I didn't really do anything, I just kind of reordered this stuff. minus 3 minus plus
Can we just put the I4 and the I together and then get I5? And then it
8.
just.
That would be multiplying. This is an adding problem. Alright, what can we do?
Put the odds together.
Okay, we put the i's together. So I see a 5i and a plus 1i, which would be what?
6.
6i. So I'll put that at the end, plus 6i. What else can we do?
You can make the fourth and one.
Yeah, I to the fourth is just a 1. So in the middle here, basically we have negative 3 plus 1,
Oh, okay, so it'd be -2.
negative 2. I'll put that in front. Real number in front of imaginary. Alright, try those evens.